In this video, we are going to understand the concept of pulse amplitude modulation. Basically, it is a type of pulse modulation. There are various types of pulse modulation like pulse amplitude modulation, pulse width modulation, and pulse position modulation. First, we will understand what is pulse modulation. So in pulse modulation, instead of the sinusoidal carrier signal, we are using the train of pulses as a carrier. Now the carrier, or you can say the pulses, are having various samples at the rate of sampling frequency, which is Fs should be greater than or equal to 2 FM, where this FM is the frequency of modulating signal which we are going to transmit. And this modulating signal is in the form of analog nature or sinusoidal nature. As you can see in this waveform, this is the modulating signal which is in the analog form. And these are the pulse train which we are using as a carrier signal. So this pulse train behaves as carrier. Now, just like amplitude modulation, in amplitude modulation our carrier signal changes its amplitude according to the amplitude of modulating signal. Same way in this case, pulse train changes its amplitude according to the amplitude of the modulating signal. You can see in this waveform, as the modulating signal amplitude varies, same way the amplitude of the pulse train varies. So this output is considered as pulse amplitude modulation. Now we will see how this pulse amplitude modulation is generated and how it will be detected. So first, for the generation of pulse amplitude modulation, we will see the transmitter block diagram. So in this transmitter block diagram, you can see that this is a modulating signal. That means this signal which we want to transmit, this signal is given to the low pass filter. Now why we are passing it through the low pass filter? Just to remove the unwanted signal, because what we are trying to do is we are multiplying this signal with a pulse train, and pulse train is having frequency which is twice or greater than the frequency of the maximum component of the modulating signal. So sometimes what happens, if suppose the maximum component is having 100 Hz, so we will keep the pulse train frequencies 200 Hz or more than 200 Hz. But sometimes some noise component may add in this modulating signal which is having higher frequency term. So then the process will not get sufficient output. So that is why we are passing it through the low pass filter, so that it will remove the unwanted signal or the signal more than the frequency of the modulating signal. Then this filtered signal is given to the multiplier, and from the second input of the multiplier we are giving the pulse train. So that means this pulse train and this modulating signal is now get multiplied and will give the output as pulse amplitude modulated signal. But this output, which is actually pulse amplitude modulated signal, is passed through the pulse shaping network. So it will shape the pulses according to the width and the height. So this pulse shaping network helps the pulses to acquire a proper shape. Then the output of this pulse shaping network is the desired pulse amplitude modulated signal. Now the demodulation or the reception part is very easy. At the receiving end, you are receiving a pulse amplitude modulated signal. That means this signal you are receiving. Now this signal is passed through a holding circuit. Now basically how holding circuit works. As you can see, this is a pulse, first pulse. Amplitude of first pulse is this. Then the next pulse arrives. Suppose that's amplitude is this, like this. What I'm trying to explain is holding circuit holds the amplitude of pulse till the next pulse arrives. So this is the first pulse, the amplitude or the maximum voltage holded by the holding circuit. Then the next pulse arrived. Then this amplitude again holds, then the next pulse, then the next pulse, then the next pulse. So this is how holding circuit works. It holds the voltage or holds the amplitude till the next sample. Then the circuit is passed through the signal is passed through the low pass filter. This low pass filter we have already seen this type of concept in digital communication. When such signal is passed through the low pass filter, it removes the high frequency component and smooth the curve. So output of this will be something like this, which will remove it by removing the high frequency component. So that will be nothing but our modulating signal. So this is how receiver works, and this is how you can regenerate your modulating signal from the pulse amplitude modulated signal. Okay, I hope you understood the concept of transmitter and receiver. Now let us quickly see the drawbacks of pulse amplitude modulation. So the very first drawback is bandwidth required is very large as compared to the maximum frequency component present in the modulating signal. Why? Because the maximum frequency component may have 100 Hz and we are using the pulse train as greater than or twice the maximum frequency component, which is 200 Hz or more. So obviously the bandwidth doubles. So the bandwidth required for the pulse amplitude modulated signal is high or large. Second drawback is, since amplitude varies, interference of noise is maximum. This phenomena we have already seen in amplitude modulation. In amplitude modulation also we increase or we vary the amplitude of the carrier signal. Because of the amplitude variation, amplitude modulated signal is susceptible to noise. Same way, pulse amplitude modulation also is interference having maximum because of the variation in amplitude. Similarly, the third drawback is, since amplitude varies, it also varies the peak power required by the transmitter. Because the amplitude is high, peak power will also be high, so the power will require more in case of pulse amplitude modulation. So these are few drawbacks. So to overcome these drawbacks, there are two other methods also, which are pulse width modulation and pulse position modulation, that we will discuss in our next video. If any doubt related to pulse amplitude modulation or any query related to any other topic, you can write it in the comment section.